and welcome to another episode of Earth911's Sustainability in Your Ear, the podcast conversation about accelerating the transition to a sustainable carbon neutral society. I'm your host, Mitch Ratcliffe. Welcome back. Thanks for joining the conversation. Electronic waste is a worldwide problem, and despite the immense value they contain, computers, mobile phones, tablets, laptops, and other electronics end up in landfills more than 80% of the time. That's one of the reasons Earth911 recently launched our free E-Waste for Trees program that collects and refurbishes devices. When you send a phone, laptop, or tablet, we plant 20 trees for every device accepted, and you get a free shipping label, a certificate that the data on your device is securely destroyed, and we'll plant 20 mangroves in Africa or Madagascar. Fortunately, we're not alone in our efforts. Electronics recycling is becoming more sophisticated, and more material is being recycled. More material is being processed and reused instead of downcycled for other uses. Our guest today is Aaron Kamenash. He is the founder and chief innovation officer at Camston Rather, a Carlsbad, California e-waste recycler that has launched the first zero-waste electronics recycling facility in the world. All the metals, circuit boards, plastics, and other materials in the electronics that Camston Rather receives are recycled. For example, it turns plastics recovered from electronics into park and campus equipment used by the city of San Diego. The company, which launched its first green smelter facility last year, claims its recycling processes are 90% less carbon intensive than legacy e-waste techniques. Camston Rather also designed a metal recovery process that reduces water usage by 92% compared to traditional methods. And it has introduced certified Scope 3 emissions reporting and the ability to provide companies carbon credits for the electronics that it recycles. There's a big story at Camston Rather, so let's dive in and learn more. You can learn more about Camston Rather at camstonrather.com. Camston Rather is all one word, and Rather is spelled W-R-A-T-H-E-R, camstonrather.com. Welcome to the show, Aaron. How you doing today?
Thanks for having me, Mitch. I'm doing great today. Thank you.
Well, good. Welcome, and thank you so much for spending time with us. You know, I wanted to start off, your background is in insurance and financial services, but you started an electronics recycler in 2000.
Yeah.
What was the insight of that aha moment that made you think, oh, e-waste recycling, that's the business I want to be in?
It's actually kind of a funny story because one of my buddies, his name is Mark Evans, he came to me. He actually was our other founding partner. He unfortunately passed away a couple of years ago. He was a friend of mine, and we used to hang out, and he'd come to me with different business ideas. I mean, my background was aerospace and nuclear engineering. I wanted to go to Mars, and I figured I needed both of those things to do that. That was not going to come to fruition in my lifetime, I thought. So I was doing banking and insurance, as you mentioned, and he comes to me and he says, "Hey, do you want to be an engineer again?" I said, "Why?" He says, "Well, I want to go." I came from a mining background. My dad worked for Kaiser Steel. He was, at the Benny plant, he was one of the foremen. It says basically on the backside of Joshua Tree and Eagle Mountain. And he says, "I have access to all these tailing piles and old mine sites that need to be cleaned up. And I want to do that and clean up, like basically fill in the hole my dad dug and basically kind of fix the problem that was created with all these gold mines and tailing piles." So I said, "Fascinating." He said, "I want to do it with green chemistry." And I said, "Wow, that sounds awesome. That sounds more like my cup of tea. And how are you going to do that?" He said, "Well, you're the engineer, you figure it out." So I said, "That sounds like a challenge and something I can roll my sleeves up." And I said, "I'd love to try to look into that." So I actually went and visited the tailings piles, visited some of these sites. They're pretty nasty places to go. And we decided to go ahead and start the process. And I did about a couple of years of research and development of creating a green chemistry that could leach all the gold and precious metals out of these different ore bodies and placer mines, things that we found around these sites, clean them up, make the world a better place. And we developed that chemistry, and it works great. And when we would test it in the lab, though, to show people, we would use like computer chips. So because you could see the gold on them, then you can see the gold stripped off of them. If you do it with a pile of dirt, you don't see anything. You just have to send it off for assay, and then you realize you got stuff out. So as we're doing this in one of our offices, I said, we plan on having a lab to when we take these different ore bodies in, and I can run some electronic waste to see how well we can take that off. And he goes, "What's electronic waste?" And I said, "Well, phone breaks or computer breaks or anything that has a circuit board, basically we look at has gold in it." And he's like, "Really?" I said, "Yeah." So he was tenacious. I mean, this guy, he would, when he got onto something, he was like a pit bull, and he would just dig in, and he dug in, and I didn't see him for 2 weeks. He just went and just dug in and said, "You have no idea what size problem this e-waste thing is." And he came back to me with it was a 60 minutes piece that had what was going on in China and how they're ruining like the planet basically. And he said, "I think there's a chance here that we can really do some real good, which people see us doing good, and we can actually make a real impact." In 24 hours, we pivoted and said, "Let's get in the e-waste business and let's see if we can clean up this mess."
So talk about the evolution of the circular e-waste recycling process that you've developed, because you're really thinking about keeping these materials in use. What were the critical steps in the evolution of the company?
Well, basically, when we started doing this and realized, hey, it's not just a gold mine literally for us that we could make money with. It was a case of, hey, this is an actually recurring thing. This stuff always comes back. How often do you have to replace your phone? How often do you have to replace your laptop? We were running through these things quite often. And I was like, I got 6 phones sitting in a drawer at home, all hibernated. I'm like, this becomes problematic. And then you see all the stuff with conflict minerals, and you see that they can't get a hold of stuff. And I'm like, what if we could then take this stuff, get the gold and other precious minerals out, put them back into the supply chain so they can be used again? We'll see them 2 or 3 more times possibly in our lifetime of our company, just to actually keep everything rolling. So that's really what came in. I said, the sustainability thing is a real thing. We throw too much stuff away. We dirty up the planet. I mean, the way this stuff works now and it always has is either buried or burned. We're creating a big mess. And we said, what if we can keep these minerals in the supply chain? Because when you look at how they get the minerals out of the Congo or anywhere out of Africa or China or anywhere they have these things, it's a nightmare for these people. And when you see what's happening when it's just sent overseas to be a profit center or dumped, it's ruining these people's lives, their villages, their entire, the entire landscape. I mean, you have places in China where it's no longer arable land, where they used to have rice paddies for centuries. And now the water is so polluted, the ocean water right on where they leave everything on the beach is like, it's at 0 acidity. It's just completely unusable, and the lifespans are dropping. And I think that with us, we said we can recapture this stuff safely and put it back in the supply chain, so this doesn't have to keep happening. And that was really the idea.
So who are your primary customers? Is it business only, or are you thinking about accepting consumer recycling as well in order to capture more of that material?
We actually do take in consumer recycling, but through some of our centers. We actually work with strategic relationships with our partners around the country and around the globe that actually bring in from consumers. And we also work with businesses where we can either acquire their e-waste. Sometimes some of them will pay us to take it. Sometimes we buy it directly in the market, whatever it takes to be able to get it in the doors so we can process it.
And you've grown fast. How much are you processing annually these days?
We are looking to do this year about 20 million pounds in this site alone.
And that's, you've developed a technology for breaking down computer circuit boards without using high temperature processes, which of course is important to reducing the overall emissions from the process. Tell us about the mechanical approach that you've developed and the role it plays in reducing your emissions.
Well, one of the biggest things that we found when we first did this was with the chemical leach that we were going to do, you created more of a mess, because if you didn't separate the metals from the polymers and plastics, you had a waste stream, because nobody's going to take what you're doing if you take all the value out of it. And now you have a leftover plastic piece or a circuit board that's just been shredded. So for the chemistry alone, what we were looking at was, let's go ahead and separate this stuff out so we can get to the part that we really need to get to with the leach. What happened was, we were doing this with small scale equipment, lab equipment. I was doing it with a coffee grinder and blender at one point, just to get the stuff out so I could test the chemistry on it. And one of the refiners we were working with came into our lab, and I had on the table just like a crucible full of just metals that had been separated and with no plastic. And he'd never seen this before. He'd only seen like printed circuit boards that were maybe shredded. And I was going to show him the chemistry and how well it worked and how we dropped it in the normal Merrill-Crowe process after we did it. And he goes, "What's that on the table?" And I said, "Oh, that's when we grind it down, we get that. It makes the connection, the chemistry work better." He's like, "Wow, that chemistry is really cool, but we know how to get every atom of gold out of everything. We've been doing it for 100 years. I want as much of that as you can produce." So we went to work to scale up and say, hey, what do we need? What type of machines do we need out there in order to do this, where we just get the metal separated from the polymers. So everything can be used in its proper bucket. And the way the technology worked was we realized, because we went to some of the biggest mining companies in the world and said, hey, here's some e-waste. Bring this down to a powder for us, please. Go ahead and separate it. And they tried their darndest. They tried every machine they could in the mining industry. And they're like, we get a 40% separation. That's a max. We even said, how about if you freeze it? Go ahead and put it in liquid nitrogen. It'll shatter like a glass rose. And they said, we'll give it a shot. And they tried, and still the same result. So we had to keep working with companies till we finally found some that could actually have machines that could put the throughput that we wanted through their machines. And we had to work with them quite a bit. It took a couple of years to do this, where we went and said, we just got to keep going smaller and smaller and smaller until we get the desired result. And that's where we want to stop. So it did take a lot of different vendors out there that we had to work with their engineering teams to say, we'll start with a normal shred. Then we had to beef up that to get to the point where we're at. Then we had to go to the next section, which is more particle reduction. And then we went into kind of a mining circuit where it was just the water separation instead of having to use chemicals. And none of it's under temperature or pressure. So we had to really work hard. It took several iterations to get to the point where we're at now, and to build a plant the scale that we did after several years of testing on smaller scale.
So how much water are you using in this process? Have you been able to reduce that as well? Because I know that water, recycling minerals in particular, can be very water intensive.
And that's one of the things that we do here is we actually recycle our water through the system. The only water, we don't have drains in our facility. Everything goes back through the filters, because when you actually come through on the filter presses that we use to compact and dry the material, they are a filter themselves. And because we're bringing the metals down to a powder, they actually work, especially the copper, to clean up anything that's in the water. So the only water we lose is through evaporation, which is very little. And then in the product itself, when it can't be bone dry. So if you're under 5% dry, you're only using 5% of the actual mass that you're sending out is water. So we just top off of taps. We don't have to empty our tanks at all. We just keep recycling and using it right through. We hardly use any water at all. So it's fantastic.
Does Camston rather also have emissions goals? I don't see them published. So have you set internal goals for reducing your emissions, and how are you doing on that process?
Well, for emissions, nothing leaves our facility. Everything's under HEPA filter. So the air going out is actually cleaner than the air you're breathing outside. We even take the pollen out. So if anything that's in the plant is actually going through the HEPA filters, that's actually exiting the building. So nothing as far as those emissions happen. The only thing that we do have, obviously, is when we're generating electricity. So, and for us, we use the San Diego's supply of electricity, obviously. We're in line to get some of the greener technology. We have solar on our roof. The next plant we build will have a lot more solar, and we'll be looking for other green technologies to produce the power that we need to run the facility.
It's interesting that you started off thinking about mining, because and we've talked about this on the show before, a ton of e-waste has more precious metals by a long shot than a ton of ore. And this leads to another question, which is, what are the prospects for mining all of the waste, all the landfills and the built environment that we had traditionally just thrown away for that value? How much value is lying around, do you think?
Billions and billions of dollars of minerals are lying in the landfills. I mean, that's our biggest competitor is probably the landfill. People just throw this stuff away. It's inconvenient a lot of times for them to go find a recycling center. They don't want to deal with it. They just, just throw it in the trash. It's fine. And that's what they do. For mining them, I believe there are some countries now that are actually attempting to mine their landfills. The issue becomes obviously, and for us, there's a lot of stuff mixed into it. And once it starts leaching into the soil, I'd love to be able, it becomes a super fun site in my mind. But it's very hard to get to it for how we do our landfills here. We thought about doing that. It's just so much abundance is being produced now. It would take me so many plants in order to get to all that's already that's been sent to landfills. There's more of it available to be produced now that I don't want going into the landfill and creating more of a problem.
So for the time being, it's a matter of keeping it out of the landfill. But in the longer term, if we were to start thinking about mining all of those residual industrial resources, how would you change collection processes and incentives to start to get that material?
I think, well, as far as the stuff that's already in the landfill, I think you're going to have to look. Yeah, I think you're going to have to look at municipalities are going to have to change what they're doing. They're going to have to look at like the MRFs that are out there. They're going to have to go back through and basically recycle their trash and be able to take out what's in there. If they could do that, I don't think on a consumer level you're going to be able to see anything like that. As far as we are looking at landfill bans, we're in different states, but it's already there. It's going to be kind of difficult for people to get it out. I mean, you're talking about large dump sites that are privately owned or by a municipality, and they've got to make the decision to bring somebody in, subsidize the work most likely, because it's going to be nasty to do it. But I think it's gonna be worthwhile. I don't think it'll be getting nastier than what they do for strip mining out in the middle of nowhere, and creating problems. And like you said, using all the water they use. I think it's doable. I think it's going to have to take some very, very big thinkers and very big machines, and to be able to do that with a lot of capital.
Well, and in terms of keeping the material that we're currently producing out of the landfill, that the whole idea of the circular economy is to build a process that recaptures it. What percentage of the economy do you think is going to shift to circularity? Can you quantify that?
It's hard to say on that, because I really think that the generations coming up now, they really are conscious of it. And I think that's fantastic. That really people are really understanding that when they have something of a waste like that, they just can't throw it away. They're really conscious, especially now, of what they're leaving, not just for their kids and grandkids, as everybody likes to say, but for themselves. I mean, you have kids that are teenagers that they're going to live to be 80, 90, 100 years old, and they see what's happening to the planet now. And they're like, wait, we're just destroying things. Why are we doing this? I think it's a generational thing where they have to come in and say, hey, we're going to change the way it's always been done, because that's what we do. And that's what we have to do to survive.
It's a really interesting discussion. I want to take a quick commercial break. We'll be right back. Now let's get back to our conversation with Aaron Kamenash. He's the founder and chief innovation officer at e-waste recycler Camston Rather. So Aaron, reporting is very important to your relationship with your business customers. How is this transparent, sustainable, and accountable end-of-life process different for the customer than with other recyclers? What changes when I work with you?
Well, what we're able to do is we're able to provide our customers with a record of what we've done through our ERP system that we use called Razor. We track everything from the time it hits one of our facilities doors to the time it goes all the way out to the refiner that we're sending it to. Everything is tracked. We can share that with the customer. We can share the fact that because we went through a life cycle analysis with a couple of different organizations that verified what we do and gave us our accreditation for that, and said, look, you can generate carbon credits because of the way you're processing, then we can share that with them. We can give them or sell them or work with them on the carbon credits. I mean, whatever we want, whatever they need to do with those to help them get the stuff in the door or to help their sustainability goals. So we're able to share that with them, where most people are going to like, hey, thanks for your goods. Bye. Here's either the money you wanted for it or the money you're paying me for it, and have a nice day. Bring us your next thing when it breaks. So that's really all they do.
So what we're describing here is scope 3 emissions, the end of life emissions that traditionally just haven't even been counted. Is that estimated by looking at the emissions avoided by reprocessing versus going to a landfill? How do you create that estimate?
You're exactly right. It's by reprocessing. You estimate it by what it would take to get the same minerals out of the system and back into the system. So that's where we look at it.
How can a business use that in its sustainability efforts and when undergoing an SEC audit about their carbon impact in the future?
Well, because of our verification, we can share that with them, so they can go and work with their accounting lawyers, whatever they need to for the SEC to satisfy it, and say, we've processed at Camston, we've gone ahead and gotten the certificate from them. They've told us how much they've processed and what the carbon footprint looks like, and here's the credits that were developed from processing our material, and they can report that back.
And have you delivered credits at this point, or are there?
No, we actually have to be operating for over a year before we actually produce them to do that. So since we just started our operations earlier this year, we're not there yet. Okay,
so you do expect it in 2024 from what I'm hearing.
Definitely. That's our goal.
We talked a little bit earlier about renewable energy and how the role it's beginning to play in your operations. You're working with Schneider Electric, which is one of the largest electric services firms in the world. They have something called the EcoStruxure Power and Process Solution. and you put this to work in your facility. How does that change the way you are measuring and accounting for your energy, as well as reduce your impact?
Well, yeah, we use with the Schneider system, we actually, because it digitizes everything, the way we bring power into the building, it allows us much easier to track and to deliver power to all of our different machines and knowing what we're utilizing at any given moment. So with our historian and SCADA system, we can know exactly what's happening with our machines, how much power we're using, when we have to cut that back. If there's certain times that we want to basically not run because we want to clean up the peak or off-peak hours. But it allows us really, as a historian with our SCADA system, to track everything across the entire facility, from the switchgear outside all the way through, to know what is happening in all of our motors that are driving the machines. And because we use soft start or variable speed drives, everything on there allows us to more efficiently run our plant while tracking all the data in real time.
It's interesting. The old days, we would measure our electric use by our billing, and that was it. What you're really looking for is how to optimize the use of every watt of electricity, it sounds like.
That's correct. Exactly.
So, you've launched a circular environment. It's really impressive. What would your advice be to an entrepreneur considering building an energy-intensive manufacturing or industrial recycling facility today? What should they go in with their eyes open to?
I think they have to go in with some really good engineering. They have to start with, what are your goals? Let's process this out properly with an engineering team that understands how this works. Because a lot of people just say, hey, I want to add solar, or I want to put wind power, I want to do this. You really have to start from design. And remember, we're a science and engineering. I'm aerospace and nuclear engineering background. Our engineers work together to make sure that when we build out a system, we start from the very beginning. So if you're going to do this right, you have to plan for it. You have to know what's out there. You have to go to the companies and say, hey, how are you going to help me build the facility I want to build? And here's my end goal. Here's where I want to get to. I need to work with you and your team of engineers to show me how your equipment or your software can get me to where I need to go. And if you're not getting clear answers from them, find another company. Find someone else that can help you do that.
So are there common assumptions you listen for when you're talking to a vendor or a potential partner that you go, that's outdated, and it's a filter device for you, or you go, not worth the continuing the conversation? What would you share with people in terms of that?
You got to have a pretty good BS detector. I mean, a lot of people are sales guys. A lot of people in different industries, I mean, when you can tell they don't know a technical word, or they overuse a certain type of vernacular where it's a buzzword, you can pretty much tell you're a sales guy and need to talk to your engineer. And if they can't answer the question, or you can see it and hear it in their voice, where you're not real. So when I was doing some banking in the past, and I'd be on conference calls and I'd hear certain words, and I'd just be like, you're not real, this call's over. And the same thing happens with technology. You're going to run into people that are trying to sell something that they may not have a full grasp of. And maybe the company does have something good, but you need to get to the people that actually work on that, and not just the guy up front who's the mouthpiece.
So in order for us to really build a low impact circular economy, not one that just pumps more emissions out and wastes more water, we have to think a lot about the proximity to materials of our facilities. You're planning some expansion. Where are your next facilities going to be placed?
Well, some of it depends on where, you're right, where the customers are. We have a relationship that we're building with certain different enterprise people that have server farms, that they have places where they bring waste back to, where they're producing the waste. And we have to look at, where is that? Now, they're all over the country. So we're looking at right now in the northeastern corridor, Northern Virginia, around the DC area, around right there, and down in the southeast right now. We already have some facilities that we do regular recycling in the south, but probably Louisiana, Tennessee, places like that. And obviously there's places that are producing out in Arizona and New Mexico that are looking for facilities like ours, where we can actually put a plant, whether we're doing the initial shred that we do and then shipping it back to a plant that we call a mothership type of plant that does all of the finer grinding and separation to get it there, whatever is more logical, because I don't need to put a bunch of these plants around. I need to have the local impact to be able to shred it. And just so you know, what happens in the industry now, and it's logistics. When you're
Mhm.
talking about recycling, you're talking about logistics. The only reason that most of these people shred is to get the air out of the box. They can only fit so much in the box if it's the whole board. If they take the air out of the box, they can fit more weight in to make it better logistics for shipping. We do the same thing. So we really focus on that.
We think in terms of logistics, which is usually associated with distribution, but it's the reverse logistics that we're talking about. That suggests that there are a variety of new job roles that are going to evolve around your facilities. How big a job creator will a Camston Rather recycling center be?
Well, if you're doing one of our recycling centers that pulls in whole device recycling and then does the separation part, you're talking about a couple hundred people in a location, everywhere from people that sweep the floors to people that actually do the ITAD, which is the data destruction, to people that do the reselling, because that's a big part of our business in the first touch. As you get a lot of, I don't want to have to destroy everything. If I can get more shelf life out of it and get it out there, I think you had a podcast with someone from eBay recently where they talked about that's a big part of their business.
Yeah.
That is a big part of ours as well. If I don't have to destroy it, I don't want to. I'd rather have somebody get more use and life out of it, because that keeps it out of the landfill and keeps the carbon footprint down as well. So for us, that's what we're looking to do.
Yeah, the whole idea of embodied carbon, and once it's in there, if we can keep it in use, it reduces the need to make more stuff, which is new emissions. But these are all complicated offsets that we do in our heads today. We haven't really embodied this in our common knowledge. How do you explain your service to a business customer for the first time? What's the differentiator that you highlight in terms of Camston Rather's ability to be a circular recycler?
Well, I think for what we do in the space we're at for doing the circuit board and extracting the precious metals and the polymers, we're a domestic solution that doesn't burn anything. We have offer you a place that you can safely have your e-waste destroyed, where you can have the data destroyed completely. And if you're not familiar with, the NSA has a standard of 2 millimeters, where if you have a data bearing thing that can hold memory, you have to bring it down to 2 millimeters. They haven't really been enforcing that, but they're starting to. We go way beyond that. So for them, they're, hey, wait, we can say to somebody, we're going to bring your stuff down so you can't read the data off it. We're going to do it safely. You can come to the plant and watch it being done. And then we're going to show you how we generate carbon credits for doing it. So that's really, in a nutshell, what I can tell a business owner or an enterprise customer, and say, we do it better, we do it faster, and we do it more efficiently.
And you keep it domestic. There's an important meeting coming up of the participants in the Basel Convention, which controls the shipment of e-waste in particular around the world. And they're talking about introducing new regulations that would also cover functional electronics that are being shipped, not recyclable electronics, but things that are functioning. And that's intended to prevent people from packing recyclables in with it. But will that create problems for the industry? And do you avoid those problems because you focus on a domestic process?
Well, I mean, we do that by focusing on domestic process, but if there is something, and I do want to say that one of our team members, Renee St. Dennis, who used to head up Apple's sustainability efforts, she came out of retirement to join our team when she saw that we had, when in her words, cracked the code that they were looking for the last 30 odd years. And she saw what we were doing, and she said, I want to be part of this. And she actually does go to the meetings with Basel and comes back and said, restricting the movement is probably going to be good for us when they try to do that, because we don't do anything that would be untoward or illegal where we're trying to pack stuff in and say, oh, it's something else. We want to make sure that it's done right. So whatever regulations are required, we will adhere to. And I think it's going to be a win-win, because you're going to get people not be able to ship it out, and they're going to have to process it domestically with us. So for us, it's a win-win scenario.
This is really impressive, Aaron. How can a business get in touch with Camston Rather to learn how to recycle and earn carbon credits? What's the first step?
First step is go to our website, take a look at that, see what we do, and then reach out to us. I think we have a link on there to reach out to, and we can go ahead and start the conversation. Say, hey, let's show you what we do. We'll invite you out to the plant and say, this is how we do it, and we'll see what we can work on together.
Well, Aaron, it's been fascinating. Thank you so much for your time today.
Well, anytime, Mitch. Thanks for having me on.
We've been speaking with Aaron Kamenash. He is the founder and chief innovation officer at Camston Rather, an e-waste recycler that has, as we've heard, cracked the code for circular management of critical materials and electronics. You can learn more about Camston Rather at camstonrather.com. It's all one word, no space, no dash, and Rather is spelled W-R-A-T-H-E-R, camstonrather.com. Circularity is a different way of thinking, and its value starts with the recognition that measurement can identify vast amounts of waste in any product life cycle. We can lower the need for energy and material inputs, reducing the environmental impacts and costs of the things that we make. We can also account for and allocate value created by avoiding environmental impacts in the form of carbon credits. Today, companies are just getting a good handle on their Scope 1 and 2 emissions, which relate to the direct and indirect emissions from a business. But most organizations are still struggling to identify and track Scope 3 impacts, which account for the majority of carbon emissions in our economy. Camston Rather's ability to track and measure the end-of-life and reuse-related emissions, water, and environmental impacts of avoiding sending electronics to a landfill unlocks a lot of new value. And that value can be used to finance a robust reverse logistics infrastructure. So now it's time to spread the word about how increasingly easy and rewarding it is to recycle computers, phones, and all the other electronics that currently litter our offices, homes, and landfills. We'll be keeping an eye on Camston Rather and the story of electronics recycling generally. So stay tuned, folks. I hope you'll take a minute to share this podcast or any of the other interviews we produced on sustainability in your ear with your friends, your family, your coworkers. Tell your boss we could recycle and not just save some of the planet, but make a little money. Please write a review on your favorite podcast platform about us and tell your friends to look for us on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the other fine purveyors of podcast goodness that they might prefer. Thank you so much, folks, for your support. I'm Mitch Ratcliffe. This is Earth911, and we will be back soon with another innovator interview. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.